Welcome everyone to the first in our DevOps series of webinars here at DuploCloud. And today we're going over Kickstarting DevOps, the essentials for startups. So today we're joined by Zafar. He's the VP of engineering, and myself. Before we get into it, this webinar is going to be recorded. So, if you drift off, daydream a little bit, not all is lost. You can review the recording later and we'll email that out to you. There's a QA at the end of the webinar, so post your questions in there or in the chat. I want to see everybody chatting it up. Really want to see, we want to hear from you. We want to engage with you. And, if you have experiences or anything that you want to add, more than welcome. So, and with that, let's get into the introductions. We have the great Zafar Abbas. He is our VP of engineering at DuploCloud, and I'll let him introduce himself.
Right. Thank you, Cameron. Yeah, I run engineering and operations at DuploCloud, guys. I'm Zafar. Been at Duplo for about 2 years, did multiple startups in my past, was at Microsoft for about 10 years or so, at Azure, running cloud operations there as well. So got some experience and kind of happy to be here talking to you guys.
Thank you. Thank you for being here, Zafar. I am Cameron McDougall. I am a DevOps engineer on the I'm a technical marketing engineer here at DuploCloud. I've done DevOps, MLOps in the past, and fun fact, I love surfing and hanging out with my Siberian Husky. So before we get started, we do have a whole DevOps webinar series coming up with some great speakers. So the next one is going to be with Adam Burns. He's awesome. And we've got some really fun ones coming up after that. So make sure that you register now. There's the link on the screen, and let us know if you have any questions about that, anything you want to see in the future. And make sure you sign up. Don't miss them. And with that, why does DevOps matter for startups, Zafar?
So yeah, I want to just set context before we actually start and get into it, right? Why does DevOps even matter? And actually the fair question to ask is, why does it matter for any engineering organization, right? DevOps is more than a function. It's a mindset. It's a mindset where operations are front and center for you as you build your applications, build your system, build your company, right? So establishing a high performance engineering culture, it's very important to be very conscious of how your operations are going to work, right? And usually how well your DevOps function is architected impacts directly how the rest of your organization is going to work. If you build a highly competitive application and an application team, but you have not so well built out DevOps best practices, the things are not going to work because the effective value of your work is going to be reduced. So very, very important to focus on the DevOps function built out early on, right? And there's no, one model fits all companies and teams, right? They're like, depends on which stage the company is at, what's the size of your team, is it a large team or a small team, what your best practices are, what kind of product you are going to build, and so on and so forth. So there's a lot of factors there. Let's keep going. All right, so let's talk a little bit about what the flow is going to be today. We're going to talk a little bit about how the DevOps function evolved, right? What did it look like 20 years ago? What changed with the advent of public cloud and AWS came into the picture? Now, having said that, all those tools and technologies available to you now, what should you optimize for? What are the main things that you should think about in your tech stack and the results that you're looking for? And then finally, as we evolve, we're going to talk about platform engineering at the end, because that is where a lot of this ends in terms of, as your organization grows, you're looking for at tools and technologies more so than having a large team. So let's keep going. All right, so let's talk about how DevOps looked like maybe 20 years ago, right? This is like pre-AWS days, where you have some products are served on the internet, some not. Most of the products are basically packaged software, which is kind of packaged and shipped out to customers. The servicing lifecycle on all those products are super long. But then as services started moving to the cloud, there is a sysadmin role that started to come up where, this one person or a couple of people in a team who are just solely responsible for servicing, making sure that the services are healthy and they're interacting with the development team, getting requirements and so on and so forth. So kind of it created a silo and a boundary between this central DevOps team and the rest of your application crew, right? So that's like this central sysadmin model. As we and then kind of it has its own implications, right? It has a single point of failure impact there, and then it's kind of the impact of the, like I said, silos between the teams where requirements are coming from the application side and they're going towards the this team, and kind of there's oftentimes friction between the organization as well, and so on and so forth. Now, AWS came in and they started pushing this model of DevOps mindset, where the entire application crew, the entire team, entire feature team was responsible for ops, right? So this is like the entire team is going to build the software and they're going to be responsible on the front line servicing the software as well. Now, has that model evolved? And that model has been very effective. And then the whole industry has picked up that model and kind of run with it, right? But what I would say is that as we evolve, right, in a large team of 10, 15 engineers, not everybody is competent at the same level. What we've seen is that usually engineers self-select themselves into an ops role, where you end up this model of what we call shadow operations, where you now have 4 or 5 out of the larger team, people who are familiar with the cloud, who are dealing with AWS or Azure and so on. And then the team ends up bottlenecking there, and they start consolidating what we call tribal knowledge of infra, right? Which has caused, I'm sure a lot of people can attest to it, that as you get more of those information siloed in a group of teams, you don't have a formal team built out, but you have a shadow team who knows how to get things done. So things start getting bottlenecked there as well, right? I think there's a few anecdotes here. Cameron, do you have anything on the tribal knowledge aspect of things?
Definitely. And I think that DevOps, for as amazing as it is, it can be really hard to implement, especially when it comes to like company culture and the way that things evolve at startups. And I've definitely seen it before where, I've been on a team where I was one of the 2 newer guys, and the 2 guys that had been there forever, they didn't have time to share knowledge, and B, I think at the end of the day, it was just like tough to get everyone up to speed with all of the mess and the technical debt and all that. It's you could teach, they could teach us, but then there's like all of these nuances because of the technical debt. And myself and the other guy, we never got up to speed, and we were never able to help with like at least half of what the DevOps team did. We were very effective in what we were able to do, but a team that's fragmented like that, where you got people focusing on one thing, and it's kind of like chaos. Everybody's running around like chickens with their heads cut off, and it's really tough. So when you have that tribal knowledge, that isolated knowledge, and there's no documentation, there's no means to share that with anybody else, it can really cause a lot of stress when things go bad. So DevOps is tough sometimes. So
yeah, and that's totally right. And I think as organizations grow beyond that model, where they are realizing that the only solution is to democratize the set of tools that they need to hand over to the rest of the developers to actually execute, that is where you start seeing the patterns of a platform, right? Where a platform is not necessarily just a service or a UI or a set of modules, right? It's basically a set of tools that a team chooses to build out to scale their operations a little bit more, right? And that's what we're going to talk about a little bit more at the end as well, right? So this evolution going from the central point of failure team to more of a distributed team, but not unconsciously built out, right? But a little bit unconsciously built out rather, and then moving towards a more systematic approach, which is like a set of first-class tools and technologies and interfaces that allows teams to grow a little bit more. Let's keep going.
Yeah, and just to chime in on that, I think that when everybody's running around like crazy and putting out fires and all that, it is really hard sometimes to take a step back and, how do we fix this? The high level view. And that's where these platforms come in. So, I think that they're so great in that sense. So,
yeah. So let's talk a little bit about what, given a a team or a company, what is the right model for DevOps to be addressing, right? I mean, we have, and there's no one size fits all. I mean, are you choosing to do a monolith infrastructure versus microservices? Is that a conscious choice, or is that something that's kind of enforced by the architecture? Do you have a roadmap going towards service-oriented architecture? The choice of service-oriented architecture or not really influences how your DevOps deployment strategy is going to look like, right? If you go to service-oriented architecture, scalability and interdependencies between services is really important for you to address. So having a model and a system that allows you to scale that is key. The other point is that, what are your underlying dependencies? Are you working with a proprietary service that's a managed service in a particular public cloud, or are you agnostic of that? Do you want to build cloud agnostic services like Kubernetes, or do you want to build closer to a particular public cloud technology, right? A few examples I list here. If you are in containers and you want to choose a cloud agnostic container orchestration system, Kubernetes is a good choice. Today, all of our public cloud providers provide the same level of support. So you can carry an application that is hosted on Kubernetes from one provider to the other. But there's also a trade-off there also, right? A trade-off of complexity, training your team on a new technology, and so on. So a lot of the teams choose to stay with a more simpler technology. I would say ECS, AWS ECS is a much simpler technology to operate. Time, it has a trade-off of, hey, now you are actually bound to AWS from a core platform perspective. So the other factor is that how do you manage your infra? Are you persisting infra as code? What technology are you going to use? Are you going to use Terraform? Are you going to use CloudFormation? You will notice that more mature and competitive teams start coding their infrastructure as code, so that their costs on an ongoing replication, cloning environments, copying environments, maintaining them, change control, it's all done. They think of their infra as their application code. So that is the right way of thinking about it. But it's a very, very key point to think about. And then finally, what is the security and compliance aspects that your products kind of need? Are you gonna in a particular regulatory environment where a certain compliance bar is going to be enforced? Are you going to be an air-gapped data center, which is you don't have internet connectivity? You need to architect your applications such that happens. So all of these factors play a key part in deciding what is the right DevOps model for you, right? Because at one point, if you want to consolidate expertise of these decisions in one team, it might be the right choice for you to have a consolidated team who is like the best subject matter experts of these different topics, versus having the information distributed out. Maybe there's a central team and then there's a consultation model, versus you can defer all of this stuff to a platform as well, that we're going to talk about a little bit more. But yeah, let's keep going. Okay, so now we talked a little bit about the decision and architecture factors that might influence which model you would pick. But at the same time, there is some, I would say, model agnostic KPIs that you need to understand as well. Regardless of which model you pick, I just want to remind everybody there are some key metrics that you need to start with no matter what, right? Whatever DevOps model you implement, it should accelerate your functions. Like the lead time to change should be small, right? The amount of time it takes for your DevOps infrastructure to roll out changes is going to determine how fast your company and your team is going to move. So lead time is super important to note down and optimize for. Deployment frequency is a very close second and very correlated with lead time as well. The faster it takes for you to deploy and test changes, the more often you can do them, right? And then you can fall back and you can fix bugs and you can learn from them. You can do A/B tests and so on. So deployment frequency and what different kind of deployments you can do is a super key metric, right? Now, the next couple of them are more about failures. So failures happen, right? In the cloud world, failures will happen no matter what, how well you build and architect your applications. I remember one of my early managers at Microsoft, when I moved from a team which was doing box software dev to a cloud technology, the first lesson he taught me was there's like only 2 words to remember: expect failure, right? And those two words create the plan for how you're going to work, right? Because at every line of code that you write, expect that this line is going to fail at some point. What will be the fallback? Similar lessons apply on the DevOps function as well. Anything that you build in your pipelines, you should have rollback strategies and so on, right? So expecting failure is kind of the one like platform and model agnostic thing that you must remember. And then with that, right, failure happens, and so it's really optimizing for the time it takes for you to recover, right? For any change, either infrastructure or application, if something breaks, how quickly can you detect it, and how quickly can you recover from it? It's kind of key KPI to look for. And then similarly, change failure percentage. How many changes are resulting in failures versus successes, right? Failure, and that's going to tell you which part of the system to focus on. If a certain module in your app or in your DevOps pipeline is failing more often, you need to do a postmortem and go back and write stuff up, talk to the team, and kind of get on that right away, right? So all parts of the system needs to be operating at a point where the change failure rate is as low as possible. And then finally, resource utilization. That metric tells you, are you over provisioned or not, right? This is where we have seen a lot of small companies pay a huge price for this because they have not observed their resource spend. And this is like simple KPIs to measure, create reports which tell you, what the percentage utilization is, and that tells you, do you need to scale up and down at times of day or and so on and so forth, right? Do you need to adjust instance types to a lower type and so on, so that you can spend less, right? So all those stuff comes in with reporting. Yeah, so that's basically, no matter what the summary on this slide is, no matter what model you pick, you must look for these performance metrics.
For me, these performance metrics, I think it's very easy as a DevOps engineer to get lost in like, oh, hey, we got to make sure that these are collecting, and the details of collecting and processing and then paying for the observability platform that you're using. Some of those can get very expensive, but the fun part, I think, that's where the rubber meets the road for me, is the performance metrics. Like, what did you build and how is it actually doing? And then going back and saying, hey, this is taking a little bit longer. If you're pulling from an ECR repository and there's like a delay, how can I speed up that delay? And how can I make the system more efficient? How can I make it perform better? It's like building a car. How do I make it faster? And so it's the fun part for me. And it's really fun to pay attention to that and see where all of the work and the thought that you put into it is making a difference. And what you said, Zafar, about expect failure, I think is just key. There's a whole ecosystem built around expecting failure. We were talking about the chaos monkeys. I think, chaos monkey is what it's called. Netflix built this because they actually introduce failures regularly into their production system so that they can build around it. And here, I'll paste the link to that in the chat because I love it. And disaster recovery, like if you can practice that and be ready, a well-oiled, run the drills, and as soon as the fire starts, what to do, you're going to be fine in a disaster, and you'll be just fine. And it's kind of the end all be all. Like, audits that require all of that are like tedious to go through and meet all the requirements and stuff. But at the end of the day, the point's not to pass an audit. The point is to be ready so that you don't make the front page of the New York Times when you have a data breach or security issue or whatever it is. So it's, I don't know, all of this stuff. I really like looking at it. Road meets the road. So
So the other thing I would say, Cameron, here is that with the change with the failure and expecting failure and mean time to recovery, that theme, right, where it's very important for organizations to build out a blameless postmortem process entirely, as in look at failures objectively. This is where a lot of the teams trip over like internal dynamics and so on. It's really important for a leader in your DevOps organization, or rather as an engineering org, to remove any cross-team issues around who did what out of the picture completely, right? It's really basically a system, everyone owns it, and then when something goes wrong, everybody owns recovering from it, right? And then you write stuff up to the detail of what happened and what needs to happen, and then you just keep asking whys, right? You ask the 5 whys, you get to the root of the problem, and you fix it, right? And that the organization fixes it as a whole. It's not like one team fixes it because the other team broke it and this and that and so on, right? So that's a super key point I want to make.
Yeah, exactly. I mean, postmortems and reviews are all about learning, and it's a rite of passage, you know. Like I think most people know that everybody is going to take down production at one time or another. And like I haven't done it yet here at DuploCloud, so you know, find some wood to knock on, but everybody's going to do it. So why blame each other? You know, we make mistakes, and that's how we learn and grow. So and that's how we get better as a team. So yeah, I think that that's an amazing culture to implement and to, you know, like you said, lead.
Right. So. Right. Okay. Let's keep going. Okay. So let's move into, we talked about the central DevOps model and a more distributed DevOps model, and then pros and cons, things that matter, things to measure and improve. So let's talk a little bit about, as the team grows, oftentimes the central team or the shadow crew, if you will, start getting maxed out, right? So with that, you will see competitive teams start to build modules and tools so that they can hand over their work in the form of automation to other people in the team, and that is really the beginning of a platform layer, right? At that point. So now the choice to be made is that, hey, do you collect a set of tools and then use that, or do you start abstracting stuff out in a consolidated place, which is really what we are saying, right? Do you end up investing yourself versus you go to the market? And that's where, you know, the choice of a platform abstraction layer is there's a lot of players out there. So it's very important to be conscious of what your needs are. Are you going to a point where you're going to get to a point where you're going to internally start managing and building out a platform team, which is going to do a lot of duplication with the work that already exists out there, which can probably acquire for much cheaper, or not, right? So that's basically a decision point here. Let's keep going.
Yeah, and on that thought, I think platform engineering and the whole idea is, you know, it's one of those buzzwords that people love to gush over and talk about and never do anything about. But platform, it really can help an organization for, like you've said, democratizing access to the infrastructure. And Gartner did a poll, and 80% of Fortune 500 companies are going to be adopting platform engineering by 2026. So, you know, I would call it the latest, greatest thing, the hot news in DevOps. And like, I think it's really cool. There's a lot of cool stuff. We'll show a few more slides in a minute, but
yeah. So as we talk about platform, let's just try to put draw a box around what a DevOps team would do, right? So that we can look for what a platform would do as well. A DevOps team, end-to-end DevOps lifecycle, does a lot for you, right? From an infrastructure provisioning to application provisioning to building CI/CD to separation of environments, make sure all the teams have the right permissions, applying security, do monitoring, receiving alerts, reacting to them, creating policies, turning on all the security controls, working with the security team to make sure, and the compliance teams to make sure the right things are done at the right times. There's a lot here, right? So this picture basically tells you the full-blown automation lifecycle, which you could hand out to a team or an individual and say, hey, just take care of all of that, and by the way, figure out everything to get done right? Or you can choose to say, hey, how can I automate this, the entire thing, right? Or at least 90% of it, right? And that's where basically the question we are asking here. Let's keep going. So this list is basically more drilled down into what a platform abstraction could provide, right? It definitely, the first value add is that it makes life simple, easier to understand. The public cloud is complex. AWS, Azure, GCP, they don't make it easy for you to understand all the concepts. So a platform definitely abstracts the complexity for a user, right? And it keeps users in a lane. Like it should make it hard for you to deploy something that is not compliant and not secure. Like makes you follow best practices, right? A platform is usually evolved based on hundreds of users of use, so that if you're using 100 if 100 companies use the platform, the 101st company is going to accrue value from the experiences built out from the previous one. But a platform basically is a software layer which evolves and grows, as well as the number of customers that it's served in the past, right? So that's like a key thing to take away. So that whole concept then allows the teams who use the platform to not worry about the minor details or the second and third level details in the cloud platform, right? The underlying cloud platform. So that allows them to free up their time, so they can go spend time in application development and thinking about business solutions and so on. So they can pull their applications faster to market, right? A lot of the platforms built in the compliance controls out of the box, or as much as far out as possible. So that's a huge time saver as well. And you don't have to kind of staff a completely independent compliance and security team if you can defer a lot of this stuff to the platform. A good platform often includes monitoring and observability toolset as well, which you would otherwise have to go look for other third-party services to integrate and then have somebody on your team go do that work. So if you can defer that to the platform, that's amazing. Cost management, like we talked a little bit before, resource utilization measurements are super important, but you need a layer to kind of present that in a way which is actionable. So a platform can do that for you as well. AI, this is an evolving area, but AI is generally, let's go back to
Sorry.
AI is a very new area. We are looking at a lot of companies come in with DevOps tools which use AI, which can look at your existing infra and infer what you should do, and you can actually use text interfaces to actually deploy services and so on. So that's only possible if you are talking to a platform which has visibility into your infrastructure, right? And then on top of that, and not all platforms provided, but 24/7 support with subject matter expertise is an invaluable asset. I mean, we take pride in that at DuploCloud because we do offer 24/7 SMEs as part of the DevOps platform as well. But if you want to add up all these bullet points and look for building out an internal DevOps function, right, and compare that with buying something off the shelf, that's a very good trade-off to look at very carefully. Because if you are especially a company that is growing and in the compliance and security space, and you want to use the latest and greatest technology, you want to defer a lot of these functions to the platform layer as well. Yeah. Let's keep going. Or anything on that slide for you, Cameron, that you wanted to talk about?
Probably lots. I mean, I think overall, at the end of the day, any platform, like you said, I just want to highlight that, is to enable the application developers and a startup to focus on what they do best and develop the application, not worry too much about the nuances of the infrastructure. Those are really, really important things to do, but you can cookie cutter a lot of that and tailor it as you go. But yeah, so platforms, I think they're awesome. Here we've got some IDPs. So IDP is internal developer platform in the wild. And so there are a lot of really good options out there, some of them open source, some of them startups. And so a lot of really good options. We're on there. So, we like ourselves, but we recognize that the competition, there's some great things happening in the space. So
yeah. So one item, or unless you want to talk about this, Cameron,
go for it.
Okay, so one item that I want to concretely talk about is that, and that's very close to our hearts because we do this every day. Like one of the biggest cost savings is automation of compliance controls. And DuploCloud, I can say from DuploCloud's perspective, but other platforms may also do this, but we automate up to 70% of provisioning time controls that are compliance controls, which are all on these like compliance standards. So PCI have like up to 80, HITRUST same, HIPAA and NIST have a large number of hundreds of controls, which you would otherwise have to manually manage and maintain outside of the platform if you don't have one, right? So, and a lot of these are, like I said, there's 70% of them are provisioning time, as in they have to be implemented at the time of resource provisioning. So you can't go back in time and fix them, right? So it's very important to start off on the right place and get them done right, right? And then if you make this right choice up front, a lot of this compliance controls work in the
We're back. Everyone can see us?
Are we back? Yeah.
Awesome.
Okay.
We're live.
Okay. Let's
All
continue.
right. We missed everyone. So I'll just go over this slide again real quick. I don't know where we lost you. So this is my home lab on the left, and you can see that you have servers that you have to worry about, disks going bad, power going out, breaking into the building. And that's where AWS came in and said, hey, we can democratize this for everyone, because again, these servers are only in one spot. AWS is worldwide, and you can deploy a worldwide application on the public cloud. And so AWS takes care of the infrastructure, the physical security, the updating the operating systems. And then the customer shares the responsibility, where the customer is worried about data, authentication, making sure that data can't be breached on the application side, all of the application code. So there actually is a fair amount of responsibility on the customer side, which is where the platforms come in. And looking at DuploCloud, this is what we offer, and this is very common across the board, that a platform is going to take on a lot of the responsibility off of the customer. So again, they can focus on what they do best, what a startup does best, and let's develop their application. So in this example, for our part, we take care of the platform. We take care of permissions. It's all very, very streamlined, and it's awesome. Like, it's one of my favorite parts of a platform and what we offer is that least permissions are just baked in, and it's really easy to use. The developer tooling is just great. And so you can see that the customer still has some responsibility left. They're worried about their application code, customer data, and the authentication and all that, which is all just part of the code. And that's, again, them focusing on what they do best. And so that's what a platform has to offer. And I think that's why Gartner is saying that 80% of Fortune 500 companies over the next couple of years are going to be adopting platform engineering, because it really does streamline and allow for focus, which is huge. If you're balancing all of these, everything that's going on, what's the word for that? Where you're shifting focus all the time, the context
switching.
That's really costly. Yeah. And so that's really costly for an engineer. So that's what platforms have to offer. And yeah, Zavar, anything to say about that?
Yeah, I would just say that if I were to compare platforms at the cloud level with what at a higher level doing the same thing what this container orchestration systems do, like at the bottom of the stack, you can do a Docker run, right? You can do a Docker run on 100 of VMs, and you can claim that, hey, I'm running containers, right? But you need a system to put them all together. Like, that's where all the container orchestration systems came in. ECS, Kubernetes, EKS, they are just platforms, right? They're just platforms that allow you to scale Docker.run across hundreds of VMs. The same apply, but nobody did that abstraction at the cloud level yet, right? So these platforms, what they're attempting to do is, including DuploCloud, and this is how we actually usually talk about the platform, is that we are raising the abstraction bar beyond where they currently sit, all the way to the cloud, right? Where all the stuff that you expect from the cloud regarding permissions, users, provisioning, monitoring, all of the things that you expect from a DevOps team to do in managing the cloud is all abstracted, right?
Yeah, and there's that word. We've talked a lot about it in the days leading up to the webinar, the abstraction, and everything is an abstraction. DevOps, I think, is in another word, abstraction, and it really helps for, again, that context and that focus. So
yeah,
let's go to the next one here. Take a look at what we've talked about today.
Yeah. So this is basically just a recap of what we did today. We talked a little bit about DevOps and there's some impact on engineering and engineering culture, and how you should think about various models, what data points you want to collect, right? And then we talked a little bit about platforms and what choices you should make. If you are a growing team, definitely worth looking at the pros and cons of that. And that's basically it, right? I mean, super interested to see if there's any questions here, but this is basically all the content we had. How you guys?
Yeah, so let's see. Right before we get into questions, another shout out to our next webinar, which actually, Janessa, you were talking about overcoming hurdles. We're going to be going over navigating DevOps hurdles, practical solutions with Adam. It's going to be a great webinar. I'm very excited for it. Adam's awesome. So make sure that you sign up for that. Click that link, and we'll send you out some reminders for the next one. And let's get into questions. So let those bring those questions in. What is DevOps? What DevOps issues are you facing at your organization? What big questions, what burning questions do you have about DevOps? What keeps you up at night thinking about DevOps? I know I think about it when I go to bed. So, maybe I'm not the only one. Let's see what questions we got in here. All right. From Janessa, are there any covert DevOps issues that an organization, where'd it go? Are there any covert DevOps issues that an organization may have that they may not realize, or that they are, or are they usually pretty obvious? Zafar, you want to address that?
Yeah, I think you can find, so I would generalize the question as in, what are the places where you end up depending on specialized knowledge, right? If I'm understanding the question correctly, that, what are the things that end up putting your organization at risk, right? Which you might not realize. I think a lot of what you would find is that if you raise an issue which can only be addressed by a certain individual in the team, that in itself is a systematic and process failure, right? So I would say that count the number of times where you have to depend on tribal knowledge or something that's not a well-known process yet, or you have to depend on an individual, and something is not written down. That is an indication that there's a systematic issue there, of systematic issue of understanding, systematic issue of creating a troubleshooting process, and so on and so forth. I would say that I've seen DevOps teams fall into that trap pretty often, where they end up depending on this single point of failure, and they double down and keep depending on that. That's not a healthy place to be at. You would see people claim that we are, a well-functioning DevOps team because that one person over there is handling everything. That is not actually a good solution. So I would say that is a red flag.
Yeah, I agree with that 100%. I think that you can work as an organization very well while having very serious underlying issues, and you won't run into them until you do. You won't see them until you expand and you hire more people, or till the system gets overloaded with, you go viral on the internet and your system gets overloaded with new users. And see, I always like to say that an application is not complete until the documentation is detailed enough that somebody can take it over without you being there. If you get hit by a bus, as the common saying is on DevOps
Exactly
teams,
right.
or, if you go on vacation, like you don't want to be on your cruise ship and having to pay for satellite data so that you can fix something when you'd rather be dancing. So let's see, we've got another question here. Oh, go ahead.
Yeah, how can we integrate security and compliance into our DevOps processes without slowing down development? Yeah, I think it's just a mindset change, right? Slowing down development is a relative term. I mean, if we call development to be, hey, I just wrote the code and merged it in, that's like the end of my development cycle, then that's wrong. I think the basic understanding of what a development cycle looks like needs to be understood, right? Right. The development cycle includes when you write the code, get it reviewed, get it merged with all the holiday gates, get it deployed to a test environment, get it test, like the whole SDLC, right? And I would argue that if you do the security and compliance best practices upfront in the pipelines, in your deploy pipelines, in your post deployment checks and so on, right, you would actually eventually move faster, right? Because if you don't do them, you are pushing debt down the line, which somebody's gonna spend some time in the future to address something that was not discovered and addressed at the root, right? So I would say that integrating, and we shouldn't just integrate all in one, right? Let's slowly, incrementally build the various checkpoints in the SDLC so that we can roll in those compliance checkpoints. But eventually, I promise you, you're going to move faster.
Yeah, and I would actually add into that's where test-driven development is very important. DevOps is a culture at the entire company, less so than a specific job position. And so if you bring in that test-driven development and bring in those tests very early on, then that's going to speed up the process as well. Mm-hmm. So if your dev team is bringing in that DevOps culture onto that team, then those tests will be just natural, integrated from the get-go. And then the DevOps team automates those tests and makes sure that everything is going smoothly, that the tests are passing and all that. So, from the very beginning, it's a culture thing.
Right. Anything else that came in?
Yeah. Thanks for the questions, Janessa and anonymous user. We've got Anon in the chat. Oh, we got one more one. How can we discern if we're overpaying for DevOps? That is a great question. That is a really good question.
Yeah, I would say, and I love your thoughts on this too, Cameron. I think we should do the math, or so if I'm reading the question right, am I overpaying for DevOps resources that I have allocated today versus not, right? I would just do the reverse the math and say, what is the cost of not having it, right? If I don't have it, what do I need to do? How would I fund? And maybe the question is completely valid. The scope of operations might be small, and you might have a very expensive DevOps engineer. You might have over provisioned, databases and so on and so forth. So there's a lot of checklists to go through to figure out if you can optimize your operations. But from a function perspective, if the question is that, hey, should I have a DevOps function? Am I overpaying for it? Do the math for if I didn't have it, what would I pay? And then if I have the function, and the question is about I have the function, I need to optimize it. Then optimization goes to beyond a certain, to a few things, right? Where am I allocated, hosted? Am I over provisioned or not? Is my cost in control? Should I do some optimization checks and so on and so forth? So, and this plays back into the cost optimization recommendation process that usually good platforms have, where you just need to look at your recurring costs and see, are you paying for the right things? But I would say at a functional level, do the math for having DevOps or not having DevOps. It's like the cost of both, because the cost of not having it is also not small.
Absolutely. Sitting here thinking about this, I think that this could be its own webinar. So maybe we should think about adding this as a bonus round webinar series at the end, because looking back at places that I've been, I was a contractor for a few years, and every 2 or 3 months I was on a new project, and then I was on a platform team at an AI company, and we had 4 engineers for the whole organization. And I think that we had too many engineers. But going back to what we were talking about earlier with the tribal knowledge, the 2 engineers on that team knew a lot of stuff that just never got passed down. And I think that ended up being a very costly decision, because we needed more engineers to cover everything. Whereas if we had consolidated that knowledge, like we could have consolidated the team later on, or instead of hiring on a 4th person, we could have done a contractor for a time. And that's something that I've seen a lot with, as a contractor myself. Like sometimes a DevOps team just really needs some extra help. Sometimes you just need a few months or 6 to 8 months of like, hey, let's get these out. Let's make sure that our observability is where we're at. It's things that a platform can help with as well, and make sure that you have the insights into the system, that you have, that everything's functioning right. And then you can kind of cut down those costs again. So, I think that's, I could probably talk for another 40 minutes on this one. I think you could too, so far. So yeah. That's an excellent question.
Yeah, it is. All right.
So any last questions? So feel free to reach out anytime, after, if you wake up in the middle of the night tonight and you have more questions, please reach out. We're very happy to talk about it, add another webinar series or anything like that, just have a one-on-one with you. So, please do reach out, and thank you so much for being here. It's, we appreciate your time. We know that is very precious time. So sitting here and watching us blabber on about DevOps, that means a lot. So thank you very much. And we're here. We'll see you at the next webinar. So have a great week. Have a great rest of your week and weekend, everyone.
Thank you all. Thank you. Bye.